number 2, with regards to um, high availability with rooted OSPF campus network design. Now, get ready for us to completely configure from scratch a new network design which is robust, versatile, resilient, speedy, and when I say speedy, very quick with convergence. It fails closed. Um, it's layer 2 friendly, uh, but embraces the greats of layer 3 and all the advancements there are with modern layer 3 technologies. Now, in this topology again, you see our um, switches there. So, core switch A and core switch B. Now, in the old days, traditionally, you would have had core switch A becoming the root of the spanning tree topology. So, this could have been a spanning tree topology where this link forwards and that links forwards and this links blocks. And if this link blocks, this will forward and that will forward, and of course it's already blocked. And this would have been the root, and this would have been semi-watt, a secondary root. And what it would have done is it would have had an FHRP between this core and that core, and so the gateway will be written as 1 here, but then it will be going through a system like VRP or HSRP, which will maintain a topology based on what's available. And so the access layer has no idea of which one has gone down, but the cores do know because they can probe each other and they can get the access layer to route traffic where it should go or pass traffic where it should go. A few key points to be aware of. If you're using a Cisco switch, for example, it's a layer 3 switch, and you need these interfaces to become routed interfaces. Quickly, let's type this command in here. So you'd go down here, and wow, that font is quite big. But you, for example, you do int interface f01, and let's go, and yeah, in your config mode, and then you do no switch port. That makes it a root interface. Then you can assign an IP address to that interface, and then you will enable the interface by doing no shut. Okay. But we don't need to do that here because we're actually using routers here to represent our intent. So, but if you're using something else for this lab, please pay attention here. So now F01 and F01 and F00 and F01 here are the resilient paths. OSPF uses equal cost multipath. These are links going from A, access A or building 10, going to core A and core B, and core A and core B are linked with a layer 3 link, and so it supports good routing all across. What you want to do is adhere to Cisco's recommendation of using something called local VLANs, meaning that the VLANs locally on this switch, for example, it's only known to this switch here, and this router or collapse core knows how to get to access devices in these VLANs here. But that's it. No other access switch knows about these VLANs. You know, in the old days, what they used to do was they trunked up here, trunked here, and tagged all the VLANs that's here over there, all the VLANs over here, over there, over there. And that actually introduced trouble because there were times that users would actually plug in something erroneous, something faulty, a switch which could have a higher priority, switch priority, which could start disturbing the spanning tree topology because they all have to try to recalculate who is in charge and who is the root, and that could bring the whole network down. Or if there was a loop here or a broadcast here, instead of going through here and not finding what it needs and dropping, it would go here. This switch has no intelligence, so it passes that across, that across, that across until you have a big loop over here. CPU gets tired of processing all the gigs of broadcast coming through, and this becomes out of action. That becomes out of action. That becomes out of action. So you don't just lose a neighbor, as in a router network, but you lose everyone because it fails open. You know, it goes across in circles. So with router network design, if you can't get to this guy, that's it. But of course, you have a path here to go somewhere else. So there's no need for going through here and going there and coming back here. So let's go ahead and first and foremost, let's configure our first and foremost, let's do the uplinks. This is how I like to work. So let me just go here and let's select a subnet. Now, as you can see, I'm doing like a point-to-point, and it's a point-to-point link in the end. And I'm going to select a subnet which would not waste address spaces. So I'm going to go for a /30. By the way, you can use a /31, but I tend to stick with 30 because not every switch or router supports 31 at the moment. I've dealt with some which don't support 31 at the moment, but 30 is safe, it works, and you still have your addresses there. So find out, let's do a quick subnet. So subnetting this, so 32 minus 30 we give you 2. 2 raised to the power 2 is equals to 4. 4 minus 2 is equals to 2 2 usable hosts addresses. Alright, so that's what we aim to get. We want to be able to get only 2 addresses where these uplinks are concerned. So let's select a subnet. I want the subnet to be quite interesting. I'm not going to use anything in that family of the loopback. I want the loopback to be unique. So why don't we select 172 and let's use, for example, 16, and let's use our network. Let's call it a 200 network. And first and foremost, I want this one to be this is building 10. So .8/30, and 8/30 will give me, it's going to give me, and I'll use this one here as the gateway. And I want this one here to be .2. And then what I'm going to do, and perhaps it will also help you to design that way, all I'm going to do is I'm just going to add 4 at the end, and 8 plus 4 of course is 12. And so guys, let me just correct that, please. It's I meant 10. I'm going to use 9, the odd number 9, and then 10 here. When I meant 1 and 2, and then over here, so I'm going to add 4 here, so it's going to be 13. Alright, so I'm keeping the evens closest to the access and the odds as gateways. Okay, so that's what I'm doing here. So 172.16.200, and then I'm going to duplicate that. But over here, because it's a master network, I'm going to make it a 0, which means it's this is going to be .1. This is going to be .2. And always make sure you save your configs. Okay, Control S will do it. Okay, so I've got my loopbacks. I've got my interface IP addressing. So what I'm going to do is I'm going to design the interlinks, do the cores first, and then once I do the access, I can just go ahead and start pinging. Okay, so I'll go ahead and let's review that one more time. So 172.16.200.0 will give you 1 and 2 usable hosts. So 1 for the core A, which is going to be our designated router, and then this is going to be your backup designated router. Okay, so loopback 99, that's 100, and you know OSPF would look for the highest loopback address or IP address and make it its router ID, and would make that its election protocol or parameters, qualifying whoever has that to become the designated router. But if you don't want that, you can definitely go and specify your router ID. But I don't need to do that. So yeah, so let's start this up. I'm going to start this up. I'm going to start this router up here, and once it launches, and here we are, I'll go in. So, and I'll need your help here for us to configure. So please, may I please get your attention? Yes, no, don't look away now. Okay, so why don't you do our interface fast not 0 conft interface fast not 0 description. I'll just say interlink to backup designated router, and IP address 172.16.200.0. 1, 255.255.255.252, and I'll say no shut, exit. Interface F0/1, IP address 172.16.200 and is .9, 255.255.255.252. This is the description. Downlink to access A switch, L3 switch, and then I'll say no shut. Interface loopback 0, IP address 10.10.10.100, 255.255.255.255. Control Z, copy, run, starts. So as far as the core is concerned, I've done that bit. So I'll head over to core B, start it up, and then we can check the pings. And we're going to configure the interfaces just as we did for core A. It's important that you make sure you can see what you're doing and do it clearly. So like I did before, I'm going to go to conf interface fast not description interlink by the way, you can use any descriptives you want to use, but I'm just doing it for lab. I may not even call it this way in production world, but here you go, just to help us. So IP address 172.16.200 and the .2 over here. 255.255.255.252. Let's bring it around here so we can see what you're doing exactly. Slide it down a bit. Okay, do you see clearly, guys? Thank you. All right, bring the interface up. No shut. Interface, we're gonna go F0/1, description, downlink to access a layer 3 switch, IP address, and we choose 13.172.16.200.13, 255.255.255.252. No shutdown. Interface loopback 0, IP address 10.10.10.99, 255.255.255.255. No shut. Yeah, in the Cisco world, you have to enable every interface. That reminds me, I need to go back to Core and make sure that interface is also enabled for the loopback. Okay, so we've done both sides, but let me just ping whilst I'm here. 172.16.200 and let's ping .1. So I'm going to lose one and discover the other. I shouldn't lose anything at the moment because the app discovery took one ping off, but then the rest discover the rest. So hence this is fine and that is almost fine. But 90% is good. Well, 80%, yeah, and this is 100%. So that's good. All right, let's go back to my terminal and Core show IP interface brief. Loopback, is that up or down? Is up. Okay, so I've already enabled it, which is great. I've enabled these two as well. So just say include only the app interfaces. Do this. Very important. So these three interfaces. So interface 0 or 1 loopback. They're all there. And I'll do the same for B. So show IP interface brief, include up, and they also are up. Okay, loopback is up as well. So let's minimize that. Okay, and I'm gonna go down here. So let's go to our friend, the access switch, and configure it as well. So start that up, and once it's up nice and safe, we will go and configure it, and then we do our first ping tests and all. Okay, so let's console in. Never said I want to delete it. Okay, so let's console into it. An area. Okay, so Conf T. Now I need to describe these very well. Okay, so interface F not description, uplink to Core IP address 172.16.200.10. Just bring this here so you guys can see what's happening here really. And let's bring it down a bit. So we're configuring this part, okay? So no shot. Interface F0/1. Now we're going to configure that part, okay? So I like to clear slate IP address 172.16.200.14. 255.255.255.252. Description, uplink to Corby, no shot. We want this switch, layer 3 switch, to participate in OSPF, so we definitely need to give it a loopback interface. So OSPF can use that to maintain almost like its table or topology, showing where things are located as far as the logical presence of that as a switch is concerned. So let's go ahead here and configure our loopback interface. I can describe it if I want to, but I don't need to because it's just loopback really. So IP address, it's a 10.10.10.10 255.255.255.255. No shot. Copy run. Start. So let's ping where I am now, which is link going down this way. So 172.16.200, and of course it's 13. I expect to lose one and gain the others. One more time and it's fine. Now 13 minus 4 is 9, and I expect to lose one and win the others. So what we've done so far, guys, is we've configured all the IP addresses here, there, and the loopback interfaces. So in the next video, we're going to go ahead and do almost like static routes to test how we can reach services, or maybe we can just go ahead and do our layer 3 routing protocol, OSPF. But I would like us to introduce a data center where this guy here connected here should be able to get to, even if this link is down, so you use different routes to get there. Okay, so why don't you come back on the next video, part 3 of this routed OSPF campus network, and take it from there. Thank you for watching, and I hope to see you on the next video.